My name is Janet Prevey, and I'm a graduate student at UBio here at CU Boulder. Well, I got into this field study partially because I love being outdoors, and as I've grown up and had different jobs, I started working with plants and I got really interested in plant ecology. So now I'm looking at how climate change will affect plant communities, and I think it's a pretty relevant question and it's really fun to do. I originally got interested in plants as a young kid, I think. You know, I was always playing in the dirt and looking at plants and bugs, and I guess not much has changed. As I've gotten older, had some great science teachers, and found out you could get paid to play around in the dirt and look at plants, so I decided that's what I wanted to do. So my research project is focused on how the plant communities in the Colorado Front Range are going to change as a result of changes in precipitation associated with climate change. So what I'm doing here, this is my field site, is a manipulative study, and I have 5 different treatments where I've changed the amount of precipitation in the summer, and I'm going to change the amount of precipitation in the winter. So some plots I water, some plots I block precipitation, to try and test out a few different scenarios. So we know the climate's going to warm as the climate changes, but we don't know what's going to happen with precipitation. Some of the most recent estimates for Colorado is that we're going to get more winter precipitation and less summer precipitation. So that's one of the treatments you can see behind me here. I have these rain-out shelters blocking summer precipitation, about 50% of it, and then I'm going to water in the winter to try and simulate this future scenario. And then I'm going to measure the plant communities and see how the non-native and the native plants react to these changes. Okay, so this is one of my rain-out shelters. It's about 2 by 2 meters, and it's designed to block about 50% of the precipitation. So these clear plastic slats will block the rain, and the rain will run down off of the plots. And it's supposed to be high enough so that the wind can go through, and the fact that there's spaces between them allows the light to reflect so it doesn't warm too much. And I've got a temperature sensor in the middle there called a hobo that will measure temperature and light levels, and I'm comparing those to the control to see that hopefully it isn't causing too many differences in microclimate. So actually, if the climate's going to warm, we're expecting to see more precipitation as rain as opposed to snow. So historically, most of our winter precipitation is snow, and that's a lot less available for the use, or less available for plants to use. But now we're seeing more precipitation like March and October and November that's rain. And that's being used by these non-native plants like cheatgrass that are winter annuals, which means they germinate in the late fall, sort of grow slowly over the winter, and then grow really early in the spring before the native plants are active. Give one message to the general public about climate change, what I do. I guess it would be to think about how important the composition of our plant communities are, and to be aware that there are these non-native and native plants. And the ratio of non-native to native plants, or the amount of non-native to native plants, is really important for a lot of ecosystem services. So you might look out here and you just see a field full of plants and it's like, who cares? But if you have these winter annual plants growing like cheatgrass, it doesn't have very good nutrients for animals. It grows really early in the spring and uses all the resources, so the native plants that grow later aren't able to grow. So it actually reduces the amount of forage available for animals and insects. It has a lot of cascading effects that maybe people don't know about. Okay. So why does my research matter? Well, a lot of people are doing research on how plants are going to react to warming, or how plants are going to react to enriched CO2 levels, or even nitrogen deposition. But I feel like there's a hole in the literature regarding how plants are going to react to changing precipitation patterns. And that's partially because we're so unsure of how precipitation is going to change. I think it's really important to know how these plants are going to react, and also if an area is overgrazed or you've plowed it for a long time and you want to restore it with native plants, you want to know what native plants are going to be most viable in future climate scenarios. And information from my study will help inform My name is Janet Prevey, and I'm a graduate student at UBio here at CU Boulder.